Hello and welcome to our lesson on applications of normal distribution. So what we're looking at in this lesson is a continuation of what we've been working on for two topics now. Two topics ago, I don't remember what the numbers are. 2 topics ago, we discussed different types of distributions, and then there was a focus on normal distribution and the empirical rule. And then in the previous topic, we just talked about the empirical rule again, but what if we had certain z-scores that weren't exact? So if we wanted to know percentages of data that weren't exactly 1 or 2 or 3 standard deviations above or below the mean, or if they weren't between those exact markers, we saw how to use Desmos to try and figure out those percentages or probabilities. So today is going to be basically doing the same thing, but instead of looking at either generic situations where we didn't have any data, or even specific data where we were looking for percentages, we're going to look at actual applications. So some actual word problems where the data has some meaning, and we're going to try to find percentages of that data that fall above or below or between certain values. Okay, so just a little recap. Normal distribution, remember, is symmetric about the mean, the median, the mode. Those are all exactly at the center of the data. So they are exactly at the center. So in your normal distribution, you have this shape that we see here, where again your mean and your median and your mode are all at the exact center. And then there's symmetry. So there's exactly half of the data below and exactly half the data above that mean, which has a z-score of 0 because it is neither above or not adding or subtracting the standard deviation at all. It is at the mean. And then the empirical rule told us the percentages of data left of, right of, and between values that are exactly 1, 2, or 3 standard deviations above or below the mean. So if we went to a z-score of 1 and then a z-score of -1, that would be adding the standard deviation once or subtracting it once. The empirical rule says there's 68% of the data in that, or in between those two z-scores, so in that region, and we know that that cuts that into an exact 34 and 34% for each of those because it's symmetric. And then if we went 2 standard deviations above or 2 standard deviations below, if we were between -2 and 2, a z-score of -2 and 2, there would be 95% of the data encompassed there. And if we split the leftover, there's 13.5% to go in each of those areas. And then if we were 3 standard deviations above or 3 below, that is subtract the standard deviation 3 times or add it 3 times, that there would be 99.7% of the data between those two z-scores, which would give us, let's see, 2.35% to go here and 2.35% to go here. Then there was a last little leftover 0.15% outside of 3 standard deviations of the mean. Okay? Oops, sorry, don't worry, I'm going. So we also saw that if a value didn't have an exact z-score, we could calculate its z-score. The z-score for any value would be found by taking that data, whatever that value is, by subtracting from it the mean, and then dividing that difference by the standard deviation. Okay? And then Desmos, always helpful. In this case is helping us find the percentages, which are probabilities, for generic z-scores or for specific values. And that's going to be the focus for today, finding percentages or probabilities for specific values, but in actual word problems. Okay? So this should be a continuation of what we've been doing, hopefully to help us pull it all together and give us a little bit more practice. All right, so for our first example, it says to assume that the waiting times for customers at a popular restaurant before being seated for lunch are normally distributed with a mean of 12 and a standard deviation of 3. So it says the average waiting time for this before you're seated at this restaurant is 12 minutes. So 12 is our average that goes right in the middle. And then if our standard deviation is 3 minutes, then we're going to add 3 and subtract 3 to fill out the rest of these little markers here. So 12 plus 3 would be 15, plus 3 would be 18, plus 3 would be 21, and then minus 3 would be 9, minus 3 again would be 6, minus, oops, Why am I putting minus? Minus 3 would be 9, minus 3 would be 6, and minus 3 would be 3. So we know 99.7% of these customers are waiting between 3 and 21 minutes, or that 95% are waiting between 6 and 18 minutes, or that 68% are waiting between 9 and 15 minutes. So that's our empirical rule. That's what our curve would look like. And again, this is a z-score of 0, z-score of 1, 2, 3, minus 1, minus 2, minus 3 for 1, 2, or 3 standard deviations above or below that mean. Okay, so that's our situation. Now, first question, well, technically one was draw the curve, but there it is. First actual question says to find the percentage of customers who wait at least 12 minutes. So 12 minutes was at the mean. At least 12 means 12 or more. So what percentage of the graph is that? I don't think we need a calculator. That is half of our graph. So we're going to say 50%. Okay. How about number 3? Find the percentage of customers who wait between 9 and 18 minutes. Well, 9 we already knew was 1 standard deviation below. 18 we already knew was 2 standard deviations above. So we want to know the percentage of customers who wait between 9 and 18 minutes. That's this region here. Again, we don't need a calculator for that. The empirical rule already told us that there was 34% there, 34% there, and 13.5% there. So if we add up 34 and 34, we get the 68 that was within the 1, and then we add the 13.5, and 68 plus the 13.5, just so I don't do anything silly. Let me use my calculator to say, oh, come on. My fingers are too fat for these buttons, sorry. So that's going to be 81.5%. 81.5%. Okay, number 4 says find the percentage of customers who wait less than 8 minutes. So 9 was here, 1 standard deviation below, and 6 was here, 2 standard deviations below, where 8 is going to be somewhere in between those. Okay, so if we want to know the percentage of customers who wait less than 8 minutes, that's not a percentage that the empirical rule can give us. And that's our clue then to go to Desmos. So let's go to Desmos. And remember, we're going to go to our functions, distributions, and then we're going to choose normal distribution. And this isn't generic. We know that this particular situation has a mean of 12 and a standard deviation of 3. So I'm going to put 12, 3 in my parentheses. I'm going to hit my zoom fit button to show me the curve. I'm going to check the little box here so I can find probabilities. Now what I want in this situation, you can see by the green here, I want to know the green percentage I've highlighted, which is going to go forever this way, but the maximum is going to be 8. So if I want to know what's going to be less than 8, I'm going to make my maximum 8. And now I can see that the shading on Desmos is what I've shaded in my picture. So if the percentage of customers who wait less than 8 minutes, the decimal here is 0.0912. Go away, calculator. So we had a decimal of 0.0912, and that is the decimal was about 0.0912. I rounded that, but that's going to be about 9.12%. And that's a reasonable answer based off the picture and what we saw there. Okay, how about the customers or percentage of customers who wait at least 17 minutes? So 17 minutes, that's going to be between 1 and 2. So we said this was going to be 15 here, and this is going to be 18 here. So 17 is going to be like here-ish. Okay, if I want to know the percentage of customers who wait at least 17 minutes, that's 17 minutes or more. Again, not a percentage the empirical rule is going to give us, so we're going to go to Desmos. This time, 17 is our minimum value, so I'm going to put 17 in here for the min, and we don't want a maximum, we want it to go forever to the right there. So I can see the shading on Desmos is the same as what I've shaded on my paper, and I can see my decimal is 0.0478. So this decimal was about 0.0478, which we're going to say is 4.78%. And it doesn't specify where to round here, so if you had rounded that to, let's say, 4.8% to the nearest tenth, that would be fine too. Okay? All right, moving right along. more of the same, just some different scenarios so we can practice plugging numbers in. Number 6, suppose the ACT scores for high school juniors are normally distributed with a mean of 20 and a standard deviation of 5. We're going to try to find the percentage of students who score less than a 24. Now, just because it's good practice, let's go ahead and draw our curve here. If we've got a mean of 20 and a standard deviation of 5, then we're going to go up by 5 once, twice, 3 times, down by 5 once, twice, and 3 times. So it says here to find the percentage of students who score less than a 24. So a 24, that's going to be around here somewhere. The students who score less, that's all of these guys here. That's not something the empirical rule is going to tell us. So again, we want to make use of Desmos. So let me take out the 12 and 3 and say this time we have a mean of 20, comma, a standard deviation of 5. Now let me zoom fit again just to fit my picture in there nicely. And this time we want no minimum. We want it to go forever to the left. We want our maximum to be 24. And now again, my shading matches what I have on my paper there, so I can see my decimal is 0.788. Decimal is about 0.788, which is 78.8%. So 78.8% of these high school juniors score less than a 24. 24 is a decent score in the SAT. Not too surprising that a small percentage, it's a smaller percentage that scores above that than below. Alright, how about the hourly wages for fast food workers are normally distributed with a mean of $10 per hour, and a standard deviation of $3 per hour. What percentage of fast food workers make more than $15 per hour? So again, just good practice. Let's draw our curve. Mean of 10, standard deviation of 3. So add 3 once, twice, and then a third time. Subtract 3 once, subtract it again, and then a third time. So just, again, recap. The empirical rule is telling us, this is ridiculous here, but 99.7% are going to be making, of these fast food workers are making between $1 and $19 an hour. I don't know how you're making $1 an hour. Pretty sure that's illegal, but maybe you're counting tips and don't get the hourly. I have no idea how that works. I've not worked at a fast food place before. Anyhow, let's see. We want to know, in this case, what percentage of fast food workers make more than $15 per hour? So 15 is going to be around here, right between the 13 and the 16. What percentage make more than that is this percentage here. Not something the empirical rule is going to tell us. So let's go to our calculator. Let's change this to a mean of 10 and a standard deviation of 3. And let's zoom fit to make the picture look good there. And this time we want a minimum value of 15, and we want to go forever in the other direction. And there's the highlight on Desmos looking just like my paper. And so my decimal is 0.0478. 0.0478. Which means we are looking at 4.78%. And I guess just so that we're clear here, this would be, when you're doing this on your practice, you're going to get the decimal first and convert your decimal to a percent. And then it's going to ask you where to round the percent. So all the way through, once you're at this step, you can make it 4.8%, or you could leave it 4.78%, or you could even say 5% depending on where it asks you to round. So this would be rounded to the nearest tenth. But you want to get the decimal, make it a percent first, and then round, okay? So this would be to the nearest tenth, 4.8%. This would be to the nearest hundredth. I've already got it rounded to the nearest hundredth. And then to the nearest whole. Oops. the nearest whole would be 5%. So when you're rounding, if you're rounding to the nearest tenth, which is a spot, you have to look at the very next spot. So if after the 7 there's something bigger than a 5, the 7 has to round up to an 8. If after the 7 there was something below the 5, or a 5, could go either way, you would leave the 7 a 7. Okay? Hopefully we're not struggling too bad with rounding. But get your decimal first, make it a percentage, and then take the percentage and round it to wherever you're specified to round. All right? Let's try another here. So we have, in this case, the number of hours Americans sleep are normally distributed with a mean of 8 and a standard deviation of 1.5. Do you think that's true? The average American sleeps 8 hours a night? Well, I'm assuming it's hours a night. Oh, yeah, so toward the end, hours a night. The mean of 8, standard deviation is 1.5. So I'm going to add it once. That's 9.5. Oops, 9.5. Add it again would be, what, 11? Add it again, that would be 12.5. Subtract, that would be 6.5. Subtract again is going to be 5. Subtract again is going to be 3.5. So 99.7% of Americans are sleeping between 3.5 and 12.5 hours a night. And let's see, what, 68% are sleeping between 6.5 and 9.5, 9.5 hours per night. That seems pretty reasonable. Obviously, sometimes you're like a normal, maybe you sleep on average 8 hours a night yourself, but there's always that crazy night where you gotta stay up finishing all these practices and a module quiz for your crazy math teacher, right? So there are exceptions. Okay, so this one says, what percentage of Americans sleep between 6 and 8 hours a night? So 6 would be here-ish. Okay, so 6 is going to be there. And then 8 is going to be here. So what percentage is going to be in between there? So the 8 is a nice exact spot, but because 6 isn't, we're going to go to our calculator again. And let's change this out. So this time our mean is 8, comma, and the standard deviation is 1.5. Let's fix the picture. And we want a max and a min. The min this time is 6, and the max is 8. And so 0.409, this is, the decimal is about 0.409, which is 40.9%. 40.9% of Americans sleeping between 6 and 8 hours, according to this problem, which I don't know if it's legitimate. Honestly, I might have just made this one up. Sometimes it's helpful to be able to do that so that we can just get some practice in. All right. Last question here, and you're going to see a couple like this in your practice. Suppose there were 500 people, or 500 people were selected to participate in a sleep study. Based on the results from problem 8, how many of them would we expect to sleep between 6 and 8 hours? So we just said from the previous problem that we would expect 40.9% of them to sleep between 6 and 8 hours a night. And so in this problem, if there were 500 people, we would expect 40.9% of those 500 to sleep between 6 and 8 hours. So 40.9% of the 500 people is what we're trying to find here. And again, Desmos is going to do that for us. So let's put in our 40.9, go to our keyboard, get percent of in there, and it is of the 500. So 204.5. Obviously, we're not going to have 0.5 of a person, so we could say about 204 or 205 of the people in that study would probably be sleeping between 6 and 8 hours a night, according to, again, these two problems. And just so you're clear on the math that was done here, 40.9% of 500, you'd take your 40.9 and put it back to a decimal, and then of is multiplied by 500, and that's going to get you that same 204.5. So if you don't like doing the little shortcut in Desmos. The math is make the percent back to a decimal and multiply it by the number you're trying to find the percent of. Okay, so there it is. Hopefully, again, that's some good practice to kind of put all of this together for you. Get working on your assignment, and as always, if you need some extra help, then just reach out. I'm here for you guys. All right, take care.